That had to be a fun class. This is one of those things that you can accidentally leave on all day. Just looking up some cohesion detection stuff in this other screen. I'm very quickly coming to the end of my love affair with Pygame. It's becoming frustrating. Absolutely a blast from the past. I am elderly as it goes. I'm at the point here where this needs to be optimized memory-wise, and I don't want to do it. It's frustrating. But hey, smooth camera. Whee! Okie dokie. Let's see. Yeah, it's 10:01. How do you do to camera? You copy and paste code from Stack Overflow. I got so frustrated with my horrible camera. and I came across a very, very nice Pygame camera on Stack Overflow. If you're interested, drop me an email or something and I'll send you a link to it. But basically, using sprites and moving a pretend camera around um, makes life a lot easier. But the problem is, now this is specific to me, and this is where I probably need to do some smart design patterning. Um, most game engines slash graphical engines really don't like it when every single tile is a sprite. So right now I just have walls and characters and me as sprites. They're the only things that have cohesion. My water does not anymore, sadly. If I turn that into, we're going way off the rails now. Water is now a normal entity and it has access to everything else. It gets a lot slower. But you can collide with stuff. Those of you that are doing games, I wonder if you've run into cohesion detection slowdown at all. But the more things that you have to detect, the more code that has to be executed. And my dreams of making this 5 million tiles wide crash and burn. There are ways around this, it's just effort, basically. Like, these shouldn't be sprites. They should be just dumb tiles. Yep, they're duckies. I love this tile set. Let me pull it up really quickly. Just because we probably have time today, I want to show this. It's this, I'm sure you've all come across like the Kenny tile sets. If you haven't, they do some pretty neat free. Yeah, Godot does it for you, but once you start getting into a ton of entities, I think you have to start culling or doing like nearby checks, not the entire world, which is what I'm doing right now. Where is my duck? There's my duck, right here. Doot, doot, doot. Yeah, Godot's very nice. I'm really debating getting back into Godot, but I don't want to have wasted so much time with it. Anyway, let's talk design patterns. So I didn't quite get your homework finalized, so you have a free pass until I put it up. Basically, I'm still tweaking it, kind of based on this interesting semester we've got going on. So keep working on your term projects in the interim. Make sure you get your meeting minutes posted by Sunday, and you will have homework very soon. But today we're going to talk about MVC a bit more and MVP, the most valuable pattern. Haha, and it's actually model view presenter, so not as exciting, but I know we did talk about MVC before, but I kind of wanted to actually dig into it a bit more because it's a very useful design pattern for you all to have in your tool belts. And there's also Model View Presenter, which is similar to MVC, but it's got a slight distinction. And now there's even a newer one, which we're not going to talk about, but it is out there. It's the Model View Controller. So we've got MVC, we've got MVP. There's also MVVC, which goes a little bit deeper. Somebody from Microsoft came up with it, I think. But if you want to go to dig deep into these kinds of patterns, I would recommend checking out outside of the scope of what we're talking about today. What we are going to cover is MVC in more detail. We're going to look at some sequence diagrams, so a little bit, of a throwback to what we used to look at. I've got an example for you actually working. It took me way longer than it should have to set up because they've gone and made things difficult with my MVC framework of choice. And then we're going to look at MVP, and I don't have a code example for you, but we've got some UML diagrams we can look at. So hopefully we all remember MVC. Yes, legendary. So it's a very good pattern. And if you don't remember when I talked about it, it was probably like 3 or 4 lectures ago. Basically, this is the one where we split up the responsibilities for who is handling like retrieving data, who is presenting the information, who is kind of joining the two together. Basically, the notion here is that we're decoupling interfaces in a way. This doesn't have to be web-based, though it's very common in a lot of big web applications, but you can do this for Android, you can do it for iPhone, any kind of an application where you have to present data in some format, MVC will work. Now, the question that you have to ask, and honestly you ask this with all the patterns, does it make sense to include it? And again, if you have a very, very simple application, probably not. There's a lot of overhead with doing MVC. But if you have something where there's a lot of people working on it, a lot of components, a lot of moving pieces, perhaps there is an opportunities for reuse later on, or maybe you want to extend things like you have planned. I want to add all these extra like presentation types of things. This is a very nice way to handle that. And hopefully we all remember what decoupling means. Basically, we are separating out classes from each other, kind of pulling them apart so that they have a single focus, a single responsibility. We'll talk about that next time with anti-patterns. But you don't want your classes doing too much. It gets really mucky and messy, and it's really hard to maintain over time. So the problem here, we're decoupling again, breaking apart. Basically, for MVC, we have a model, and a model is basically messing around with data. Maybe you're pulling it out of a database, you're pulling it out of a text file, you're getting input from a user, you're reading, making decisions. Basically, there's some data that you have, or the business logic of the application, right? So it doesn't strictly have to be a database. You have a GUI, and then maybe you have different ways to show that data. Perfect application here. When we talk about decoupling, we want the data to be completely separated out from the view. So if I pull a list of user records out of my database, right? First name, last name, profile picture, account name, birth date, all of that information, the view has no impact on that, right? Your front end shouldn't care. The front end only receives that data and displays it appropriately later on. And the nice thing about decoupling that is that each one of you could make your own view with this data set, and they don't impact anybody else's, right? Let's say one of you does the login screen, one of you does the profile page, one of you does the home page, the blog page. Let's say we're doing a web application or something like that. You are all separated from each other. Your particular front end, if you make changes to it, it doesn't update anybody else's view. It doesn't update the business logic or the model or how it's routed. You are working on your own component. Single responsibility, single focus, and basically you have kind of a nice little sandbox to play in without destroying the rest of the application. That is something to strive for. Okay, so enough about that. We talked about MVC before, model, view, controller. These are 3 separate responsibilities here. Front end and the background were always separate. In an ideal world, they are always separate. They should be separate. It is very easy to hack something together where the front end and the back end are one web page. So let me give you an example of the bad version of this. Okay, so let's go back here. So this is architectural, meaning this is how we structure things. Pretend you're writing a website and you're doing it in PHP because that's my favorite web programming language, and it's much maligned in the programmer humor subreddit. But I'm writing a blog, okay? So my web page is blog.php. At the very top of that page is a bunch of PHP code, connect to the database, get the data for the recent listings, have functions for inserting blog posts, and then the second half of the page is HTML. Then you have more PHP for handling outputting data, and it's all one big mess of a page, right? So that is self-contained, which is nice for, knowing where things are. But if you have to make a change, that's going to impact everything on that website, right? On that particular module. And then try to bring in one of your teammates who has no idea what's going on, tell them to fix something, and then they fix this one little line and it breaks everything else. This decoupling rips that apart. Everything is autonomous and works by itself. But now we have a nice separation. You can make changes without impacting somebody else. So it is very easy to slip into a bad programming paradigm without this model. But again, if it's like a simple thing, you don't necessarily need the overhead. There is that trade-off. Is it super important to keep things relatively abstract on the back end? Not necessarily abstract, but accessible. So your back end could be like a class where you have add to database, get from database, whatever helper functions you need, and it will return the data or insert the data in a well-known format. So not abstract, but accessible, I guess maybe is a good way to put that. And that way everybody can use that intelligently. So there's a lovely post on, I think it's Programmer Humor, about front-end devs and game designers being horribly afraid of the server backend. That makes sense. Yeah, portability. Great point there. All right, so let's implement this thing. So what are the responsibilities of each of these components? So we have the model and the view and the controller, right? So the model is going to handle however you want to represent that data. So that's your backend, that's your talking to the database, reading data from your XML or your JSON or your text files, right? Could incorporate some of the other patterns we talked about, like the visitor or an observer or something like that. Makes sense, I would think, right? You can overlay these patterns on top of each other. But yeah, your point, portable. We don't care what the user interface is. It could be a website, which has been the example, but why not have a web application that also talks to a phone app, right? It can be the same model backend. You can have a phone application that calls an a RESTful API, right? You call website /get/id/ blah blah blah. It's your RESTful call. That is the exact same model that your website's calling. Now you have two different devices rendering the same data, different views, because, right, phone app versus web app, but the model don't care. So that's kind of one of the ways that we can break things apart. Again, there is overhead with this. There is a lot of extra mental modeling we have to do to figure out how this all works, but the benefits are amazing. But again, a lot of that front-loaded development and mental work to spec everything out. So that's our model. Model equals getting data or handling business logic. All right, so the view then is your user representation. We don't care what the view is as long as it knows how to access the data. Could be web, could be phone, could be PC, could be Linux, could be Mac, could be ARM. So let's get something going on a Raspberry Pi. We don't care. The view is independent. Controller, this is also independent. Think of the controller as your router. So I am routing traffic from one point to another. Doesn't have to be necessarily like going from page 1 to page 2. It could be understanding what the user wants to do and then calling the appropriate view. Basically, the controller is kind of your central linchpin where the user wants to do X activity, and then the controller then grabs this view and populates it with the correct data from the controller, or from the model, sorry. So here we have a nice little kind of informal model here. Informal model of the model view controller. Um, just kind of a nice little high level here. So here we have the user, here we have our view, our controller, model. The model can update the view, the controller manipulates the model, the view sees what the user wants, the user talks to the controller, and we kind of have this nice little cycle here. Depending on your figure that you look at, there's going to be a link between the view and the controller. And actually I've got that here in a very, very pixelated figure. But basically the controller picks which view we're showing. Make sense? I know we talked about this before, but this is a little bit more detail for you all. Great example too would be those of you working on like Godot or Unity games. We could have a nice little model view controller pattern there where, depending on how you compile things, your view is going to be HTML5, Windows app, native Linux app, Mac OS, right? That's your different view. The controller would then be your user interface. The model would be all of your game data on the back end. You know, same for you doing like calendar apps or calculator apps. The view is just what you show. So, kind of just a little bit more detail here for you all if you want to go through it. So this would be just like one example with a little bit more detail. But here we have some different arrows pointing. And again, the models that I'm showing you here, the links aren't strictly important as long as we have a good separation of responsibilities here. So here there's no direct connection between the view and the controller. The connection is between the view to the user to the controller. Here we don't necessarily have a user in the loop. We might with gestures, but this could be like an automated API too, or this could be like API calls or something like that. But again, separating out our responsibilities here. All right, so a little bit more detail. I want to make sure that I haven't like talked about this already. But does model view controller make sense? I don't want to beat a dead horse here if you all get it. Let's talk about the gotchas then, I guess. Yeah, this is a refresher for me. That's good. If you have never done web design, this might be new for you. If you have done web design, you probably are at least aware of this. So let's talk about some of the particulars here. New for me, that's good. So model view controller, separate components, consider them separate Java classes or Python classes. The model only knows about itself, right? It has no idea that a view or a controller exists. It is an atomic unit that only deals with data. So if you're doing this in Java, there are no references to a view, no references to a controller. We just have access functions or set functions, right? So make them public, or depending on your inheritance, protected or something like that. But we don't care about anybody else, just massage the data for us. We can have a object act as a model. I want to read this out because it's important. You can have a model participate in multiple model view controller patterns. So if you have a complicated application where you're presenting like you've got different purposes of this big project, right? One of them might be a blog, one of them might be a storefront. To keep going back to the web example, your model can serve multiple components, right? We're just kind of including it like a library. It is getting data, it is manipulating data, and it is transmitting data. We don't care who it's transmitting to, just let's import it as a reference, basically. All right, model, we can actually treat, if we want to include a slight link to a view or controller, we can actually apply a observer pattern here. So let's say that some kind of change happens to our data set, right? A new record gets inserted for our Amazon shopping carts. Well, what happens? We may have an observer that is watching the state of this model. Let's call it a shopping cart, right? You have added, I don't know, I need new windshield wipers. So you added a new windshield wiper to your Amazon cart. The observer pattern here gets triggered and notifies you by email saying you have inserted this in your cart. Would you also be interested in this, this, and this? Again, observer is that pattern we talked about last time where we automatically notify other objects. We can treat the model as the subject and anything else as an observer. So we're overlaying patterns on top of each other here. Again, we have to code that in, but it's feasible. So other things here. The view and the controller have to know about the model. This should be hopefully intuitive because the view has to know what data to render. The controller has to know what data to pull out and how to talk to the view about that. Right, so if I'm rendering out a blog post, for instance, the view has to know what data goes into this paragraph, what data goes into the author field, what data goes into the posted date, what are your privileges for editing this post. The view has to know some of this stuff. The controller has to know how to talk to the model, right? It has to know which functions to call. So we do have references basically one way here. We might be extending them or importing them or something of that nature. Okay, hiding this now, but basically the view and the controller work together. So we have the model as kind of this data store, and the view and the controller talk to it. Again, this will hopefully become apparent here pretty soon. So we have consequences, advantages and disadvantages basically. Advantages, obviously, we have a lovely reuse capability, maintenance capability, multiple people can work on things at the same time capability because we are not impacting each other by doing that. So this is called decoupling. We also have this notion of higher cohesion. And this is something we haven't really talked about yet. Basically, cohesion is a class has very limited responsibilities. It's very well focused. So if you're creating a new project and you have one class that does everything, right? It's got all of your functions, all of your attributes. That's actually an anti-pattern called the God class, which we'll talk about next time. Basically, it's got very low cohesion, meaning that it's doing too much. And if you have to update any of those pieces, you have to update lots of things, which is bad. Typically, you want high cohesion, low coupling in your models. And that means very well focused, very low connections to other things that you don't need them. All right, so these are good things. Models can have multiple views. Again, they're distinct units, so you can just add on views because they're talking to effectively a data store here. Consequences there, sorry, disadvantages here. This can be tricky to mentally understand. Singleton equals God class. Not really. Singleton is very well focused. So if the singleton was a God class, it would also have a crap ton of other things hooked into it. A God class would be more of like, let's say we're going with this blog example, it would have add user, add post, edit post, update database, render view, blah, 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 many, many things. Singleton is very well focused on what it does. So not quite right, but good, good guess. Singleton would actually be very highly cohesive. So that's a good thing. All right, so this can be tricky to navigate. We have things broken apart. There are lots of layers of abstraction here. So you have to understand how all these pieces fit together. You have multiple artifacts to deal with. So you basically have more separate pieces, but they're very well focused pieces. And there can be a very high learning curve here. So let's look at a couple of sequence diagrams here. So we haven't looked at these in a while. Hopefully you remember how these all work, but we've got a user, we've got some actors here, so your view, controller, and your model. And this would be some kind of a information retrieval process here. So we start up here at the top left. Web user needs some information. The web user sees the view, which is probably a website, right? The view will handle the event, so the user clicks a button, tells the controller, hey, I clicked a button. Again, separate modules for all of these. The controller then routes this request to the model. So click a button, controller routes the user request to the model. Model is going to be your database. Sorry, when you say big learning curve, are you referring to the learning curve? So and more, it could be multiple things, Kyle. So the concept itself, I think, is pretty straightforward, right? So separating out classes should be fairly intuitive. It's more, if I want to make an update in the application somewhere, I need to know where to make that update. So the example I'm going to show you here momentarily is going to be a web-based thing. There are a ton of PHP files in there, and you have to know exactly where to go to make the update, and you have to update multiple files to make that change stick. So the learning curve is what MVC framework you're using or which implementation, I guess. So it's probably the code base part of your answer there. But I mean, this concept hopefully is not too strange for you all, right? We're just splitting apart modules here. So controller handles the event, sends the query to the model looks up in the database, returns the results. Again, we don't care who called us or where it's coming from. We just know we have to get data, package it up, send it out. Right, so the controller then receives that result set. Let's validate it in the controller because you should always validate. Well, there should be a validation here as well because you don't trust anything from the user if you're a website. Good point to always keep in your mind. So let's validate the data. If life is good here, we update our view. The view tells the user, which could just be like rendering HTML or sending a push notification or whatever we're doing here. So pretty straightforward. We are separating out our actors here. This one is a little bit more detailed here, where basically we are trying to we're clicking a button trying to search for a person in an application. This is effectively kind of breaking out the last example that we had. So user clicks a button, the button does an action. So an example model be interacting with an API or entering data into a database. I would say, let's see, so it depends on your implementation. So if you're entering data into a database, then I guess let me step back here. So if I'm doing it from a web-based format, right, you have a bunch of text fields on a website, and that data goes into a database. The view would be all the text fields and the button. The controller would take all that data, validate it, send it to your model. The model would then be responsible for talking to the database. So the view doesn't talk to the database, the controller doesn't talk to the database. The model talks to the database. Now, if you're entering things in directly, it doesn't really apply, I suppose. But yeah, that is a good example. I like that. But effectively, your GUI is going to be your view. What's happening with sending data and packaging it up is going to be your controller. Interacting with your data store, whether it's a database, JSON, XML, text file, tape deck, anything, that's going to be your model. Model can massage the data too, right? So if I pull out 500 rows out of a database and I just want a count of something, that can also be handled in the model, right? So a select count of how many people's first names start with E. You know, obviously that could be an SQL query itself, but the model could make that kind of a decision. We just package up data and send it out here. Again, hopefully you can see where reuse would be absolutely easy to have here, right? So I've got a view and a controller. Let's say I'm very happy with my database entry front end. Well, my MySQL database We've been using it for 10 years, it's great, but we're getting into this big data realm, and now we need to do NoSQL, right? So we need a Mongo database or a graph database because we need something better. We can leave our normal model alone, and we can add another model in for NoSQL. We can add another model in for a graph database or like a big table, a column-based database. So any of your, or an XML database or an access database if you want to feel terrible about yourself. Is NoSQL faster? Um, that's a very good question. NoSQL and SQL, they're suited for particular purposes. So NoSQL is great for big data, but the detriment of NoSQL is that you don't have a defined schema at the database level. All of your interactions with the database are handled by the programmer, not the database itself. So there's pros and cons to each of them. I mean, there are reasons why most like big tech companies are using like Mongo or graph databases for their massive data sets. Um, it is very good and very fast, but there are disadvantages with the structure of the database. Basically, there is no structure. Um, there, tabular versus non-tabular data is where you're kind of going to get into things. There's nothing wrong with MySQL for a normal web application. All right, so those are sequence diagrams. Here we actually have a different view. We have not talked about these diagram types yet, but this is a package diagram. Basically, inside each of these packages would be a class diagram. And this was kind of easier to demonstrate what model view controller looks like here. Because we would call our view the presentation layer, where each of our application views would be like separate class diagrams. So we don't just have like one view class, one model class, one controller class. We can have a collection of them. They interact with your control objects, which could be your routing, could be some kind of business logic. Basically, we're sending data from the view to the controller here. Then your model side of things here would basically be a set of classes that interact with files, interact with databases, interact with however you are representing your data. So again, separating out responsibilities and abstracting things out. So here's a pretty straightforward model view controller model where we have a view class, we have a controller class, we have a model classes here. This would be like if you have a like a text box, increment, decrement buttons. We have references to the controller in the model. I know we said we don't, but you can track it if you want. The controller is basically going to route this data into the model. So separate classes for separate responsibilities here. Where did my example go? I wanted to show this example first. I guess put the slides out of order. Sorry. So let's talk about a PHP example. I know I've talked about CodeIgniter in the past. I didn't show you it because I didn't have it working. But this would be one of the web-based frameworks for model view control. You can do MVC in Java. You can do it in Python. I didn't feel like setting up a MVC application in those, so let's look at PHP. Again, class is language independent, so take that for what you will. I'm not expecting you all to go out and learn PHP now, especially now that it's crazily object-oriented and not as easy as it used to be. But this is a framework that you would install on a web server. You know, you have a database, that's going to be your backend, which your model is going to query. You can define views, which would be your various web pages. And the controller would be how you route things. So the controller would basically look at the URL, and that tells you which view to present. So if I go to the home page here, this is the view that I see. Let me talk a little bit separately here. So I'm running this on, I know I've mentioned we have GCP educational credits. Basically, I just spun up a web server really quickly in here, free to me because we've got coupons for this. It's a Ubuntu server. It's got a very nice terminal interface. And I installed a LAMP stack on here, meaning Linux, Apache, MySQL, or MariaDB, actually, and then PHP 7. So it's your standard web server. Now, I don't want to tell you how much of a pain it was to get this up and running. Um, they've made a lot of changes in recent years where instead of just setting up a database and dropping PHP files in, you have to do a lot of extra effort to get it working. So to say this took me a handful of hours instead of minutes to get going is not an understatement. But that's neither here nor there. We have this web-based framework that is set up. So let me clear this out and I'll talk through what's going on here. So this code app is my model view controller application. So I didn't want to do that. Go into our web directory. I want to be an app. So this is my directory. So I've got controllers, I've got models, I've got views. Those of you who have done web design before might remember that index.html, index.php, index.asp, default.html. Those are all the first thing that you see when you go to a website. If we look in the actual home directory of this website, we don't actually see an index.html. We see public, we see app. In this app, we see index.html, which is good. But this is actually kind of a hidden, if you happen to go here, don't do that kind of a thing. But we'll talk about that. So what I'm trying to show you here is that, make sure I remember exactly where we need to go with this. Routes, config/routes. So, vim config routes. Come on. Oh, it's capital. Of course it's capital. All I'm trying to show you, this is that learning curve thing I was talking about. If I just want to add a new view, I have to update like 3 or 4 different files to make that happen. All right, so this is all pre-baked. And I'm looking at the controller logic right now. Basically, I'm setting my default information here, the default namespace, or the default basically directory location is in this controllers directory. The default controller is home. The default method is index. So basically, I have a bunch of API calls that are saying, which view do I call by default? And now what I've added here is a specific route for you all. So CIS350, basically this is all I changed in here. This is what I had to do to update my controller to show you a different view. Make sense? Normally you just add like a new HTML file and that's your different web page. Here I've got to update a bunch of API calls. So this is the overhead that I'm talking about here. All right, so let's look at, so I've got controllers. There are no models implemented here. There's no database I've hooked into this application. So basically the model is just a data store, which we don't talk to. Just kind of for your reference there. But here, routes. Oh, sorry, that's the thing. I realized I showed you the wrong thing first. Controllers, home.php. So my routes is the controller. My controller also talks to, basically I extend the basic controller to have specific routing calls. And this is very complicated. You don't have to like memorize this or anything like that. But basically what I'm saying is I'm routing the user to this class where I want to render this particular view. So welcome message.html exists in the views folder. Right, so when I do my default routing, I'm going to say, pick up this view and show it to the user. And this view is just an HTML page. It's actually a PHP page here, but there's nothing going on behind the scenes. It's kind of your standard HTML types of stuff, and not very nicely separated. Your CSS should be elsewhere. 641. Come on. There we go. Let's change this to CIS3. Of course, it's a read-only file. I forgot to update the permissions, so I've got to use sudo controllers home. No, sorry. Views welcome message. Hi there, 350. Save and exit, and we refresh. Now we're CIS350. Again, this is not an index.html. Yeah, it's exactly like Flask routes. It's the same concept with Flask, honestly. But I updated a view component, right, with just some basic HTML, and I didn't touch the model. I didn't touch the controller for this, right? I just updated the view. Now I added another route to basically CIS350 that I told you about there, right? And again, this is config routes. Make it a little prettier. I added a route to CIS350, which in this framework means that I tack on CIS350 to the URL bar, right? So I'm highlighting it up here. If I change this to 351, I'm going to get a file not found error. It routes me to the error page. If I take it off, oops, 34, code app. I need to go to the correct loop. Yeah, of course. See, that's the HTML catch-all here. Public. There we go. Here's my home page. That's my home view. CIS350 routing to CIS350 view. Okay, now what did I have to do here? I added a controller for CIS350 to handle rendering the view for this particular thing. So return the CIS350 view. While that is in my, oops, sorry, going too fast here, my views folder. Here's the CIS350.php, and I'm just rendering a GIF. Now, is this a lot of overhead for a very simple website where I've got a GIF and I've got a homepage? Probably. But if this is a massive web application with 10 developers working on it, it makes a ton of sense, right? One of you work on the GIF view, one of you work on the shopping cart view, one of you work on the model to tie them all together. You can each add in your own separate files and you don't impact anybody else. So that is going to be, that's CodeIgniter. There's also like Cake PHP out there if you want to keep going down the PHP route. Flask is a model view controller if you want to do Python web servers. So there's basically a lot out there. All right, so I've got 5 minutes, so let me wrap this up so that we're not stuck in design patterns. So I want to talk about anti-patterns next time. So as MVC in more detail, there's also MVP, where it's very similar to MVC, except that now we want the view and the model to be 100% decoupled. They have no idea that the other exists. That was a nice to have in MVC. MVP basically fully decouples that. So let me show you. This is kind of a good view here. So here's our MVC. Again, we have our kind of our nice little feedback loops here. MVP takes the ability for the view and the model to directly communicate. So the controller basically becomes like a controller slash view in MVP. So the way MVP works is the view, it's called a shallow view. Basically, this is just presenting the interface, but the presenter side of things does a lot of the heavy lifting for us here. So the model stays the same, handles the data, formats it, whatever you want. View doesn't do anything important other than render data. Whereas before in MVC, the view could be a little bit more powerful. And then the presenter basically kind of ties them together. So we give the controller, or sorry, yeah, the controller a little bit more power with MVC. Um, Basically two very, very similar ideas, just we're kind of abstracting things out a little bit. Um, and then the question you might have is which is better, which is worse. If you're going to be looking for this kind of thing online, you're going to find a lot more references for MVC, so the documentation is a lot better, and the frameworks out there are a lot better. But there are a lot of people that like MVP. So if you take anything away from this, basically we are 100% decoupling model and view with presenter. Whereas MVC, we can notify the view that the model has changed. All right, makes sense. So MVP still architectural, very, very similar, just with more rigorous decoupling. And if any of you are into doing web servers and you're doing stuff in Python, Flask I would highly recommend you check out. It's a wonderful, lightweight web server. Like if you need to run a website on like a Raspberry Pi or something like that, super lightweight. Much more lightweight than Apache or Nginx. All right, any questions before I let you all out for the weekend? Everybody good? All right, well, I think I'm good for today as well. I will see you all on Monday. We will talk about anti-patterns, and it will be fun on the bun. All right, bye everybody. Have a great weekend. Enjoy the 60-degree weather. We went out to the beach last night, and it was gorgeous out there. So, antipasti. Yep. All right. Have a great weekend, all. Let's. I'm hungry too. That sounds good. All right. Bye.